Hello, this is Madison, and my second part of my video tutorial series on how to write a steganographic app. For one thing, uh, we have written a steganography app, and I wanted to say a few things here because apparently, and this is never even how an array works, I don't even know why, but I'm going to use this because this is what the tutorial actually says that I showed you the first time. I'll show you that again. C pixels I comma j. Normally that doesn't even work that way because it's I and then j. I bracket j and then bracket something else maybe. But if it's an array within an array within an array. But here apparently it's x pix comma y pix. I'd like to have some commentary actually about why this is even done. But let's see, Sturg J. Yeah, alright. And in theory this should work. Sturg J. Now main.py. I have to do some debugging here on camera, I guess. But it's better that I do this for you, I guess, because at least you'll know that there was a problem and how to solve it now. Programming is always a continuous struggle, I'm afraid. Anyway, between man and machine. Oh shit. Store object does not support item assignment. Let's see. Oh. Okay, I'm not even sure what to do about that. I'll probably have to. Okay, so I'm sorry about all of this. Maybe this will have to be like both. You giving tags the benefit of the doubt, don't you? Anyway, so I need it to be x. What we need it to do now is we need x equals x to -2, and this will and this will take away the last 2 bits of the number as it was, and then it will x plus equals not such glorious code golf anymore, I'm afraid, but let's see, that should take away the last 2 bits of each binary pixel there, and then add on the next 2 bits of our message. Yep. To the blue pixel, RGB. Now let's see if this works better. Hello. Invalid literal for int with base 10 and x. 2. Right. In X and 2, actually, I'm going to show you that too. Because I half remember. And X, 1, 1, 1, 2, 1, 1, 2. 2. And 1, 1, 1, 0. 2. 14. Okay, maybe I skipped a few numbers there, but yeah. Now, that will convert our binary string into a number. Let's see. Stir J. No, it doesn't. No. Stir J plus 2. That's the wrong part, actually. Then pick 0. J. Been stirred. Actually, been stirred. Yeah, there you go. That's what we should have done. So, then picks. I think that's stirred. Yeah. That's what we should have done in the first place. My videos might not make that much sense, but okay. Item assignment. Damn. Okay, this is confusing. I'm going to use a little debugging magic here. That'd be the B component, the blue component, and it doesn't seem to go under 255, which I assume means that it's RGB 255 8-bit by 8-bit by 8-bit. Yeah, that's a tuple though. Yeah, 8-bit by 8-bit by 8-bit. Now, so therefore, yeah, RG, actually this was red pixel that I was modifying, but let's see, I would need to actually take this thing, pixels RGB. RPix is reconstruction of a pixel. RPix 0 0. Alright. And now you see, because Python doesn't let you just take a tuple and then put change of value inside the tuple. You have to go by circumlocution this way, and works. The programming language, I think, has its foibles. I'd rather be doing this than C. But let's see. X should be just right. Yeah. X plus equals binsterg pixels plus equals binsterg. That's the 1001, whatever. Okay, so 2 bits of the message in binary, and then it will take the pixels x pix y pix by y pix, and it will did I even use pix? I could always just do this, so I don't actually use another variable. Pix. I actually don't need this part anymore. Uh-oh. Let's see. Y pix equals pix now. X pix 1, pix 2, x pix y pix equals pix. In case we mess with bear and copy. CP bear and copy. And Python dot py. Start it as an integer. Sterg and two this should work. X plus and stir X is the binary string here. Binary string of that, and then yeah. Base 2 and base 2 and probably just a byte anyway. Yeah. Stir. Okay, so it is encoding that byte correctly, I think, because it is a byte. It is supposed to be a byte if it's anything under 255, probably, which is what we tested it to be there when we just had it print out, I think. So, yeah, and to print and yeah. Pick 0, yeah, pick 0. Alright, so what was the error? Stir object cannot be interpreted as an integer. Okay. Oh, alright. And y, let's see, x equals and x equals and x 2 x 2. Now, let's see, x should be the number, right? Under 255, and x to invalid input is 2. Why would it be nothing? Then it's binary. Always, by the way, be sure and leave good comments on your code so that they can be read easily. I think that this is important. Anyway. One to x is x2. Binary back into int, and then. So what was the error? That's a number now. Let's see. Is that supposed to be? That's the problem, though, ain't it? Let's see. It's all the same, right? I mean, it's basically the same thing, isn't it? Yeah. So, basically, it's messing with the last two digits there. And it should be exactly the same, except it's not. Let's see. Or maybe what I need to do. I'll remove these debug prints here. Now, what if... I can't believe I'm still on this. It's supposed to be done the first time. Let's see. Anyway, so... But... actually, what we should do here... Ben picks is x.adjust. Adjust. Data adjust. Yeah, this is better. Line up those comments. And this should work, actually. And it will probably make it so that it'll just add those last two digits there anyway. But if it's black, then maybe still. Now let's see. There it goes. Oh, damn. Maybe because it's the, it's -1. Of course. Actually... I just realized something. Our pix. I'm gonna say that again. There's constructed pixel. This whole thing instead. Because maybe it's messing with the iterator value here. Our pix. Yeah. So our pix x pix pix percent fd dot size 0. If not x pix y pix plus equals 1, r pix equals pixels, x equals bin r pix 0 2 colon. So r pix 0 2 colon r just equals x dot r just a 0 colon -2, and then plus equals those last two bits, and then int, and then turns those bits into a number, and then adds that number to the pixel array, and then makes that the thing. Now it just needs to break when if j equals len bin strg. Break anyway. Now So, I think that we can assume now that the message hello world has been implanted into our picture. Now, all we need to do is find some way to get that message out of the picture later on. And, I mean, I'm sure you can be creative about what hello world could be. I mean, it is binary, so it's basically anything ASCII or anything any encoding. As long as it's an even number of word size, such as a byte, which is 8 bits, even numbered word size or something. Anyway, but yeah, so here's what it has done. It will, the decoder now should take the last 2 bits out of every pixel, and what it's going to do, and we may want to scrap this actually, or recycle it anyway, and copy, save some time, save some work, nano decoder.py, and save some pain. Anyway, now, so here's what save pix, x pix, y pix plus equals 1, r pix. Now we're going to gut this part here where it encodes the message parts into the pixels, and we're going to take r pix, and we're going to take the first pixel out of it. Yeah. Just like we did. going to take the first pixel out of it. R pix. So J plus equals 2. Don't need J anymore either because we don't have a message to be encoded here. But screw memorizing all this library anyway. Anyway, so if we just assume that it is being encoded by our Steganographic app, then we can just create a simple app which will just decode it exactly that way. So J plus equals 1 equals J plus 1% 8. J plus equals 1% 8. Actually, 2, 4, 6, 8. 4, actually. Every 4 pixels. J. So then bits, let's see. rpix msg byte plus equals if byte plus equals plus equals rpix 0 bin rpix 0 negative 2 negative 2 bin rpix 0 negative 2. Perfect code golf, by the way. So it's going to take the last 2 bits out of every red pixel that it comes across, and if byte len byte equals 8, or we could just screw it. Alright, yeah. This is better. Okay, then MSG plus equals MSG plus equals ord sure int byte 2 and MSG plus equals sure int byte 2, and that will turn it into an ASCII. Equals, I guess if we create a termination character, then we could actually have it so that it'll just stop eventually. I'm actually going to write this in now. Hello world. Percent. Percent. Okay, and percent is here going to be our termination character, and it could really be anything. But this will work, I think. That's ASCII anyway. Now, yeah. Now let's see. I'm just going to hotwire this into there. Percent. And then I'm going to take that, and then we're going to yes, print MSG. Yeah, and the decoder seems to be smaller than the encoder, by the way, which is some interesting knowledge. Okay, so it will byte plus equals. Yeah, well, byte equals. Also, don't need this. Well, yeah, I do. Byte equals 0. Yeah, 0. Yeah, I hacked you. Alright, now MSG byte equals 0. Oh, actually. Yeah, that's true. Yeah. Let's see. MSG byte rpix equals pixels. If not xpix, xpix pix, fd.size, fd.load, xpix, ypix, rpix equals pixels. And that's the pixel. Byte equals rpix 0. Bin rpix 0, -2. Byte plus equals, if len byte equals 8, then it will just tell you. And yeah, this is how it'll work. And let's see, because this program should decode our steganography. Wait. What? Oh. Hack you, bitch. Okay. I don't think I can really introduce that. Brute hate. Inconsistent use of tabs and spaces and indentation. Oh shit. Okay. Decoder. This is gonna be cool. Okay. I'm just gonna respace it again for you. Yeah, this is how it'll work. This is going to work. Oh shit. Carry on, baby. Oh shit. Yeah. Yeah. Sometimes you gotta do this. And it can be annoying. But here you go. I mean, I think this is also a tutorial on how to just debug it though. Maybe it's not working. Something went wrong. Okay. Terrible. Don't even. No, I'm just gonna go all the way through it. Pain in the tushy. How about if I just had it print right here, what the message even was right now? Yeah. Yeah. Coder. Okay. Not even correct. Maybe I need to actually one thing. rpix equals by bin rpix 0 -2, and actually maybe I should also by -2. Actually, that's the opposite. Dummkopf. Yes. So, this might even work. Not really. No, I won't even decide it's because byte is too big. Yeah, byte equals. Just set byte. Yeah. So yeah. Let's see. Anyway. Yeah, not even, huh? And that wasn't even supposed to. Another problem. Okay, let's see. Yeah, so bin actually byte rpix 0 2 colon. Yeah, so actually it needs to be both, but neither. So let's see. 2 colon and then byte. I mean, it needs to be both, though. Anyway, byte still colon -2. No, 2 colon. That means the second to last bit, or the second to last character in the string, ongoing to the end of the string. So byte, or I could just actually do this instead. Oh crap. Yeah, there you go. And yeah, the second. So when you say, as I said, when you want to use the bin function, it'll output this string of bits followed by 0b. And if you want to process it like it's just a binary string, then you want to get rid of the 0b. You want to do that by having 2 colon there from the bin. But then, since we're here in my Steganography app, extracting the last 2 bits, we're also doing this. Or we could just forget this because we're just extracting the last 2 bits anyway. Yeah, okay. So, Yeah, probably. That's the pixel. That's the pixel 0. That's the red pixel. Binary of the red pixel. And then we want to take the last 2 bits of that binary of the red pixel. And then we want to add that to byte. And if lin byte equals 8, then we want to use chur int byte 2 byte -1 byte -1 equals percent and exit byte equals nothing. Yeah? Well, what was the problem with this exactly? Maybe it was the encoder that was the problem now. Well, rocket science ahoy. But, some kind of graphical weirdness, perhaps involving ANSI escape codes or whatever. But it did not encode our message, in fact. Let's see. What is wrong now? That is 8 bits right there, right? Yeah. That's an 8-bit ASCII string. And it's encoded into 8-bit binary numbers there. And every time that other thing struck 8, it would take that as a byte. Maybe we should try and debug it some more. Nano decoder. Let's see. Byte. Yeah, just print byte then. See if it just even does it right. Won't even, huh? What the hell? I mean, this is another problem. Oh, right. Print byte. See if it's really working. Eight bits. 8 bits. Yeah. Decoder.py. Yeah. So yeah, there's no reason this should not be working, in fact. Which is alarming and distressing because I really wanted to give you a better video. Maybe you can work on this, I guess. Actually, that's not even... Yeah. Yeah. Why is there a B in it? Sure, and byte. Okay. Byte equals... Alright, hang on now. -2 colon plus equals bin rpix. Shouldn't have 0B in it though. Pixels, Y pix. Sure. Will this even work? How about this instead? More B in my binary. Well, I guess this has at least been a series about writing a steganography app, and I'm sure that better programmers or something will come along and improve my script. And I think I'll add more videos of myself debugging and writing this, working on this script actually. So there will be more if there has to be. So I hope this has been informative. Thank you very much for your time. This is Madison.